We are now set up for the final stage of our project, and this is going to be the rendering stage. We've already determined where our camera is positioned, allowing us to create a render of our image. When we do render the image, everything that you see within this border is going to be a part of that image. To render an image, just go to Render and select Render Image, or use the hotkey F12. I'm going to use Render Image now, and instantly I'll get a rendered image of my scene based on my camera's view. I can then go to the Image menu, select Save As, and then find a location to save my rendered image. So I'm going to go to my Windows file, and I'm just going to create a new folder, label it as renders, and now we can give our render a name. So we'll just render this as render 1. Press enter and select save as image. So now we have successfully saved this image to our computer. But that's not the end of the video. In Blender, we have access to what are known as rendering engines. In this class, we've only been using the Eevee render engine, which allows for much faster results using rasterization as the main method of lighting our scene. An alternative render engine to use in Blender is CyclesX, which focuses on path tracing to map out the scene. To change your rendering engine, go to the Render Properties tab located in the Properties panel. It's the one that sort of looks like the back of a camera. The very first option here will be your choice of render engine. Currently, we're set to Eevee. We actually have a lot of additional options that we can change here. So before we change our render engine, let's see if any of these make a difference. For example, we've got screen space reflections. Now, as soon as we activate that, you'll notice that there's a reflection of Suzanne, or Bob as we've named it, in certain areas of the stand, because the stand is quite reflective. If we turn that off, you can see they're no longer visible. So we can turn on screen space reflections, open this up and potentially manipulate some of the other options to alter how our screen space reflections work in our render. And then we can go render, render image, and now we've got another render but with screen space reflections applied. So it looks just that little bit better than our initial result. Now let's take a look at the Cycles render engine. Just left click where it says Eevee and select Cycles. The middle one is the Workbench render engine, and this one isn't actually used that much for rendering, it's used more for previewing your scenes. So we're going to go to Cycles, and you'll notice that the viewport gets a bit fuzzy initially. And that's because Cycles uses a far more powerful, far more realistic method of mapping the scene. Therefore, if you don't give it much time to make those calculations, the result is going to appear fuzzy and all in all not that great. If we take a look at the settings that we have, we'll notice that we have the ability to define which device is used for the rendering process. By default, this is set to our CPU. In most cases, you're going to want to use the GPU. So we can select it, but if you find that this option is grayed out, it may mean that you don't have your GPU active with Blender. To correct this, go to Edit and Preferences. Then go to the System section and ensure that your Cycles render devices is set to the appropriate option. By default, it would probably be set to none, and when I do this you can see that the device option is grayed out. Because of the graphics card I am using, I'm going to go with Optics for the best results. If you've got an older Nvidia card, you may need to go with CUDA. And if you have an AMD card, you may need to go with HIP or One API if you're using an Intel GPU. I'm going to go with Optics and close. Below that, we have the additional options for sampling, which includes the ability to sample for our 3D viewport and for our renders. We have the noise threshold, which determines how noisy we're going to allow our image to be. The lower this value, the longer our render is going to take, but the cleaner the results. This is used in conjunction with the maximum number of samples that are allowed per frame rendered. So these two work together to ensure that we get the result that we want. The defaults are actually pretty good for this, so we're going to leave them as they are. The other option that I want to highlight is this one here, the denoise option. This allows us to enable a denoise pass once the render has been completed. This will be useful if you have run into time constraints and don't want to expend that many samples or that lower noise threshold for your render. In the case of noisy images, denoising does exactly what it says on the tin. It will clear up any noise within those renders, but it may come at the cost of finer details. We're going to keep it on, but in this scenario it would probably be okay to have it switched off as well, because it's not the most intensive scene in the world. With everything set up, we're going to render one more time, but this time with cycles active. So go render and render image. You will notice that the cycles engine will take considerably longer to complete than the Eevee render engine, which was an instantaneous result. But by comparison, we are getting a result that is based more on the properties of real world lighting. So here I'm just going to go image, save as, and this time I'll just save as render 2 and select save as image. Now I've completed 2 renders of my scene, one with Eevee and one with cycles.